Alrighty. So we're just doing some basic review. Today we're going to kind of gloss over the topics. And then since we have a couple more days, since we're moving the test from Tuesday to Thursday, unless you have a moral obligation for that for any reason, in which case you can reach out to me privately, we will allow one of those days to be a practice test day where we all work on a practice test together, essentially. And I'll type one up and get it out to you. But then we'll let another one of those days more or less be a Q&A day. So you can bring your homework and any problems that you have questions on, or I'll let two of those days be Q&A days. You just come with your homework or any other questions you have about material, and then we work through it together. You just ask me a question, we work it out on the board, simple as it does. There is one problem that someone presented to me yesterday from the homework that I thought was really interesting. You have a hill, and then a tree is on the hill, and then the sun is here, and it casts a shadow, and you want to figure out how tall the tree is, given some information. This is a pretty complicated problem. What you have to realize is you have to rotate the entire frame, essentially. So if this would typically be at a 90-degree angle, say this was, in that problem, it was 36, and then this was 26, I believe, or no, 56, something like that. I just want to instead rotate the entire frame so that this angle is 20. This angle, I'm going to add that 36 degrees that I chopped off. So this is 136 degrees. This is my tree, which I don't know, and then the length of the shadow, which was like maybe 200 feet or something. The reason we do all of this is because this allows us to use either law of sines or law of cosines. Yes.
When did you have 126?
90, yes, 126. 90 plus 36 is 126. And then that tells us what this last angle is. That's 146, 180 minus that is 34. So you could then go through and use, I'd imagine the easiest thing is probably going to be using law of sines. I've got this pair here, I just need that pair there. So it'd be something like sine 34 degrees over 200 equals sine of 20 over t. And you can solve for t, multiply this over here, flip that over there. So that was that problem. I wanted to show you this because that problem I think seemed a little tricky. Who has worked on this problem yet? One.
Is this on homework that's already due?
I don't know. I think not, because it includes law of sine and law of cosine, and the second homework is only on law of sine and law of cosine.
It's the one due Tuesday.
It's the one due Tuesday. Okay, yes. So this is on the homework that's due Tuesday. So when you encounter this problem, don't freak out or plug it into ChatGPT because it might get it wrong anyways. You just have to work on rotating the frame and realizing that since this was here, it comes down at an angle that way. So it goes from what would be a 90-degree angle straight up, falls out that way. And that's how to think of it, at least. It's very useful. I'll leave that there. All right. Cool. So I will present to y'all the topics that are going to be on the exam, and then we'll talk about them a little bit and do a couple of examples with them. And I will end up probably just scanning this as a PDF and sending it out to everyone, because I don't really have the time to type it all up. So we've got our topics. We start with basic right triangle trig. That's what we talked about for the first couple of days. So this is, I give you a triangle with some sides and angles, and you tell me some more information using just basic sine, cosine, and tangent. We've got arc length and sector area. So this is, I tell you maybe the radius of a circle and the angle subtended, and you have to find either the arc length subtended from that or the area of the circle, that sector that's spanned out. So we'll do some examples on that. Angular and linear velocity. This is pretty important because it's one of the most useful things that you learn, especially if you have to go on to take any physics classes. And so we'll do, there will be a question on this on the exam. Anything I list here, there will be at least one question on the exam about it. So it's important to remember law of sines and cosines. I'm debating on if I'm going to include the formulas for these on the exam. I might include law of cosines. I probably will not include law of sines though, because it is a really simple formula. Law of cosines I might include though. And then directional distances. So this is what we were talking about when we said I go north 30 degrees east or something like that. There will be a question about that on the test, and so we will do some more examples of that so you see it more familiarly. With these come more or less our important list of formulas for this. So each little part has more or less its own formulas that are important. For the basic right triangle trig, we've got sine theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And tangent theta equals opposite over adjacent. Which is the same thing as sine over cosine. These we should have ingrained into our brain at this point. If you don't, you really need to know these. These will not be included on the test. It is also important to remember secant is 1 over cosine, cotangent is 1 over tangent, and cosecant is 1 over sine. I probably will give these to you on the test, but only on test 1. After that, we expect to be a little more familiar with them. But we haven't done too many examples with these, and I might only ask one question on them to begin with. All right. Arc length and sector area. Remember, when we're doing problems like these, we need our angle to be in radian for our formulas to work out. So these are just ratios of total area over spanned area and total length over span length when it comes to circumference. So I'll do the length first. Remember that the total length of the circumference of a circle is 2 pi r. So I want the arc length is some fraction of that, which is proportional to the angle we subtend in radian, over 2 pi, which is the total radial measure of a circle. That's an important thing to remember. I'll just put that as a useful fact maybe. 360 degrees equals 2 pi radian. You will have to know that. I won't ask you to convert between degrees and radian. Your calculator will do most of that for you. But it is important to remember that when you're using radian versus degree. With this, I have a 2 pi on the bottom of both sides, so I can cancel it. I get that arc length, which we write as S, is equal to theta, and I move the r over here times r. So I'll actually rewrite this as S, because we use S for arc length. So that's an important formula to know. And then for area of a sector, right, I want whatever my area is over the total area of a square or a circle is pi r squared over whatever my angle is in radian, and then 2 pi is the total radian. I can cancel the pi on both sides. Moving this r squared over, I get that the area of a sector is equal to theta r squared over 2. It's another important one to remember. I will not give these formula on the test. These formula can very easily be derived, but more important is to remember it's the portion of circumference over the total circumference equals the portion of angle over the total angle. portion of area over total area equals portion of angle over total angle. So the reason specifically I'm not giving you these formula is because it's important that you conceptually understand what arc length and sector area are. Arc length is a portion of the circumference. Sector area is a portion of the area. So it's important to remember those. Angular and linear velocity tie right into that. Remember, when we're talking about linear velocity, we're more specifically talking about moving around the arc length. So velocity as a whole is equal to the distance you travel divided by time. So if I'm spanning whatever my arc length is, then my linear velocity, v, is going to be equal to my arc length over time. Or theta r over t, which will be useful. Again, theta has to be in radian here. So this is for one of those questions like we had where we have a pulley or a winch winding up a rope. We're talking about the linear velocity. Whatever's going up is equal to how much it's going around the arc length when I'm wrapping it around. Then angular velocity is going to be the linear velocity divided by the radius. Right. We derive this out using all of our 2 pi and whatnot. Then angular velocity, this is the same thing as v was, let's see, yeah, I'll do it instead. So instead of first saying it's velocity over r, it's the amount of angle change over time, right? This is a distance, like a line, so linear velocity. This is angular, so angles changing over time. This is the same thing as saying theta over t times r over r. And theta r over t is v, so that's how we get v over r. Or, relating them to each other, I get that v equals omega r. So that's important. I will probably give you an example that has some sort of angular velocity, or it's easy to figure out the angular velocity, and I ask you for the linear velocity associated with that. And so that's what you have to do there. Again, we'll do more directions, or examples on all of this. Law of sines and law of cosines. So remember that this is for a triangle drawn in a particular way, or labeled in a particular way. Angles A, B, C, side lengths A, B, C. Law of sines says that sine A over side A equals sine B over side B equals sine C over side C. So this is the construction we use if we have a pair of angle with opposite side and some other piece of information. The law of cosines says a squared equals b squared plus c squared minus 2bc cosine a. So this says I need two known sides and the angle between them. So this one, we need pair of angle and opposite side plus one unknown. here we need an unknown side. Two known sides. And the angle between the known sides. So different setups will give us different examples of which law we need to use. And I feel like we've done enough examples so far to where it's a little instinctual at this point, but it is important to remember this. You'll get a lot more comfortable with this after you do homework 2, because homework 2 again is on nothing but law of sine and law of cosine. And then directional distance, there's not really formulas for this, but it is important to remember north, east, south, west. Anything here is north with some degrees east. Anything here is south with some degrees east. This is south with some degrees west. And this is north with some degrees west. So for example, north 10 degrees east is over here with 10 degrees off of north. Or south 10 degrees east is going to be down here with 10 degrees off of south. So the degree measure is always how much away from the first thing you are. The second measure is in what direction away are you. Notice that north-south always comes first, east-west always comes second. And it makes sense naturally when I talk about something, I'm going to say southeast and not the east-south, because it just sounds weird. Right. A couple of other important things to remember. The Pythagorean theorem. Says a squared plus b squared equals c squared if c is the hypotenuse. That's very useful. One thing that we didn't explicitly say in class, but might be useful if you're going to do problems with law of sine or law of cosine, is the following rule. The angle across from the hypotenuse is always the largest. That is a hint for the problem that we messed up in class yesterday. I should say I messed up in class yesterday. The angle across from the hypotenuse is always larger than the other two. That wasn't necessarily the case when we did the example yesterday, so we need to be sure of that. That's an important note to write down because that will help you when you go to do law of sines and law of cosine problems. So that's basically just an overview of more or less everything you need to know for the test. Another important one, which we talked about yesterday, and this is important for directional distances, so I'll write it down here. If I have two parallel lines and something that runs between them, the angles on opposite sides are equal. So these acute angles are equal, I'll call them theta. And then these obtuse angles are equal, I'll call them phi. That's really important for when we're doing directional distance problems and we need to figure out the angles that are subtended when we're not told what they are. So we saw that in the example yesterday. I told you I went 70 degrees northwest over here, and then it was like 20 or 30 degrees northeast this way. but I didn't know what the angle between these two travels was, so I had to calculate it. I knew that I had a subtended angle of 70 here, so I did 70 and then my other thing over here and got my total angle. Or it was 20 and 80. That's what the things were. Alright. Any questions about any of this? This is again the entirety of what you're expected to know for the test. Which it doesn't look like, I mean it looks like a lot, but at the same time, it's not too much. These are basic trig functions, arc length and sector area, angular velocity, law of sines and cosines, Pythagorean theorem, which I really hope you should know. This was just an example, so I can get rid of this to begin with. This is just a useful rule. This is just a useful rule. All these are just words. Yes.
Do we have to memorize the special right triangles, like the 30 and the 45?
No. All that stuff that we did at the end of class yesterday, if I expect you to know one of those angle identities, like for instance, sine of 30 degrees is 1/2, you'll be given a table of that information. I have that very table right here. If I deem it necessary for you to use any of these, I will give you this table. But I probably am not going to involve any of the problems where you would have to know that, because again, that's more unit circle stuff, and we haven't hit that yet. Any other questions? Yes?
Which one of those topics would like coterminals like fit in?
Probably just under basic right triangle trig, but that is an important thing to remember, so I might just leave it as a little note. Coterminals, that's either theta in degrees plus 360 times the number of degrees, or theta in radian plus 2 pi in radian. These will always have same trig values. So the sines will be equal, the cosines will be equal, the tangents will be equal, all the inverse trig functions will be equal, all the reciprocal trig functions will be equal, so that's important. One thing to remember about sine functions, which I will give you this on the test, but it's still important to remember. Sine of an angle, in degrees specifically, is equal to sine of 180 degrees minus that angle. Or in radian, sine of theta in radian is equal to sine of pi minus that angle in radian. Looks like I accidentally drew the Smash Bros symbol right here. So those are important things to remember. Sine is oscillatory, so the values keep popping up every 180 degrees, more or less. Cosine is also oscillatory, but the way to get it is kind of weird, so we're not going to worry about it. All right. Any other questions? These are great questions, thank you. I'm not going to start any examples today, so I'm just going to give you all the next 8 minutes to ask any questions you want about this stuff, what might also be on the test, anything like that, or any questions about anything homework-wise or anything like that. But otherwise, that is all of what I wanted to present today. So questions about the test, any homework, anything like that. Yes?
How many problems are actually going to be on the test?
Probably 8 to 10.
Okay.
So it's a decently short test. The example tests that I'm going to give y'all have 8 problems on them. And so I will probably do something very similar to that. Another thing to look out for, we did some problems of this in class, is composition of functions with inverse trig functions. So for example, when we had the, sine of inverse tangent of x, and we wanted to write it all in terms of x, that's something that will also be on the test, right? I had to draw up my triangle, recognize that tan x equals theta, so theta equals, or tan inverse x equals theta, so theta equals tan x. Tan is opposite over adjacent. 1 squared plus x squared, square root of 1 plus x squared. And then sine of that x over square root of 1 plus x squared. A question like that will be on the test. But we'll do some examples of those in class so that you'll be comfortable with them.
Will the test have a bonus question?
I feel like I've answered this before. The bonus question is always, what is something you studied or learned while studying for the test that you didn't get asked? I don't like giving exceptionally difficult problems as bonus problems, which is what a lot of classes do, because the tendency is for students to spend way too much time trying to solve that problem, and then they don't actually answer other problems, or they answered them very incorrectly because they ran out of time, and they lose more points than they would gain from the bonus problem. Any other questions? Alright. Well, that's all I have for y'all today. If you have any questions or anything, you can either email me or come by my office hours whenever you need to. Oh, yes.
I think we should just read can we see the difference between like the inverse sine and CSC?
Yes. This is always a common issue. So typically when we see x to the negative 1, we automatically know that's 1 over x. This is only true for numbers though. This is the inverse of a number. The inverse of a function just goes the opposite direction of what the function does. Sine, as a function, takes in an angle and spits out a number. Inverse sine takes in a number and spits out an angle. However, 1 over sine still takes in an angle. So this takes in an angle and spits out 1 over the number, but these are very different. These do not do the same thing. The input of this is a number, the input of this is an angle. So that's the important difference. Functions are like machines, right? So I'm not going to put a log of wood into a fruit chopper, just like I wouldn't put fruit into a log chopper, right? These have different inputs and different outputs. So it's important that we have the distinction between them. Good question. Any other questions? All right. Well, y'all are good to go. Again, if you need anything, just reach out.